Hi everyone, in this video we're going to be looking at polynomials and linear factors. And so at the top of the page here we just have a definition of a polynomial function. Values of a are going to represent our leading coefficients. The value of n represents the degree of each term. And then usually at the end of the polynomial we'll have a constant. We call that a sub 0. That's our constant term. So once a polynomial has been factored completely to its linear factors, it is in what we call factored form. And I have some examples here. So we have standard form of y equals x squared minus 5x plus 6. And if we factor it, this is factored form. Or we have a cubic polynomial here. This is its factored form. And then we just have a binomial here, a quadratic binomial. And here's our factored form. So you just have to understand that vocabulary so you know what you're being asked for each problem. So for problem number 1, we're being asked to write the polynomial in standard form. It's in factored form. So we just have to multiply it out and put it in standard form. So I'm going to multiply the first two, x plus 1 times x plus 1. If we FOIL that, we're going to get x squared plus 2x plus 1. And then I'm going to use the column method to multiply that out. So we're going to do x times every term in the trinomial first. Then we're going to do 2 times every term in the trinomial second. And remember, when we use the column method, we're going to line up like terms. Add them together. So we get y equals x cubed plus 4x squared plus 5x plus 2. Right, so we went from factored form of this polynomial to standard form of this polynomial. Now the next one, we're being asked to write it in factored form. So always before you start factoring, you want to look and see if there's a GCF. Is there a greatest common factor in every term that I could pull out before I start? And it looks like we could pull out a 2x, so let's do that. And what you want to do is you want to ask yourself, 2x times what is going to bring me back to 2x cubed? Well, 2x times x squared is going to bring me back to 2x cubed. And then 2x times what is going to give me 10x squared? That would be 5x. And lastly, 2x times what would give me 12x. All right, so far so good. But what we're seeing here now is that we can continue to factor x squared plus 5x plus 6. And that's going to give us y equals 2x. Two numbers that multiply to 6 but add to 5 would be x plus 3 and x plus 2. So this time we went from standard form to factored form. All right, that's it for number 2. Here we have some more vocabulary, the zero product property. That states that the only way a product is 0 is if one or more of the factors is equal to 0. And so I have some examples here. Basically what it says that if we have a times b, and that is going to be equal to 0, then either a is equal to 0 or b is equal to 0. So if we were to factor x squared plus 7x plus 10, we'd get x plus 2 times x plus 5. And if we set both of those equal to 0, we'd end up with solutions of x equals negative 2 or x equals negative 5. Same with this guy on the right. If we pull out the GCF, in this case the GCF is x, and we set both those parts equal to 0, x equals 0, x plus 7 equals 0, and solve, we're going to get solutions of x equals 0 or x equals negative 7. The factor theorem. The number a is a root of a polynomial if and only if x minus a is a factor. Just kind of like working backwards. It's saying that if we know that the solutions, the roots, the x-intercepts are -3 and 4, then we know we can work backwards and say that x plus 3 is a factor and x minus 4 is a factor. So it says find the zeros of each function, graph and label the zeros. All right, well, we know that the zeros in this case are going to be, we're going to have x minus 2 equals 0 and x plus 6 equals 0. All right, so let's see here. X equals 2, x equals negative 6. So let's go ahead and plot those. Now, if we were to multiply, we would get x squared plus 4x minus 12. And this is just a parabola. And because the value of a, the coefficient in front of x squared is 1, the value of a is greater than 0, right? We know that we have a parabola that is facing up. It's a U-shaped parabola that's going in that direction. So now we have everything we need to do a very rough sketch of this parabola. Okay, so just going to connect those dots. And we've graphed that function, right? So I think it's really important to note here that we're calling our solutions zeros. So let's make a note. Zeros are also solutions. These words are all interchangeable. Roots and x-intercepts. They all mean the same thing. And that's the point of doing these two graphing problems. All right, let's take a look at number 4. We're going to set this equal to 0, negative x plus 7 equals 0. That's going to give us negative x equals negative 7, or x equals 7. And then we have x plus 2 equals 0, so x equals negative 2. Right, let's plot those. Now let's multiply out our parabola. So negative x times x gives us negative x squared. And when we use FOIL, we get 5x plus 14. So this time we have a different scenario. This time we have a value of a less than 0. Then we know that our parabola is facing down. All right, the end behavior of this parabola, we're going to negative infinity on both ends. So we can go ahead and sketch knowing that. Just a very rough sketch. Again, the purpose of these problems is to just remind you that these solutions are also x-intercepts on the graph. You can also reverse the process and write linear factors when you know the zeros. So it says write a polynomial function in standard form with the zeros at -2, 3, and 3. Well, if -2 is a 0, then I know that x plus 2 is a factor. If 3 is a 0, I know that x minus 3 is a factor. If 3, the second 3 is also a 0, I know I have another factor that's x minus 3. So think about it. If we were given what I just wrote initially and I said solve, you would tell me that x equals -2, x equals +3, x equals +3. So the factors, the sign inside the factor is going to just be opposite. All right, so now it's in factored form, but we're being asked to put it in standard form. So we're going to multiply this out. Remember, you can use either the column method or the checkerboard method. This time I'm going to use the checkerboard method. First, I'm going to multiply the second two binomials. I'm going to FOIL x minus 3 times x minus 3. That gives me x squared minus 6x plus 9. I'm going to use my checkerboard method. It doesn't matter if you write the trinomial across the top or down the side. We're going to multiply x times every term across the top. Then we're going to multiply 2 times every term across the top. Then we're going to combine like terms. Like terms always happen in a diagonal when we do the checkerboard method. So we're going to get y equals x cubed minus 4x squared minus 3x plus 18. Okay, moving on to number 6. We're given zeros at -4, -2, and 1. Right, that means that we have factors at x plus 4, x plus 2, and x minus 1. Right, we want to put this in standard form. I'm going to multiply the second two out first. And this time I'm going to use the column method. So I'm going to take positive x here and multiply it by every term in the trinomial first. Then I'm going to take 4 and multiply it by every term in the trinomial. And I'm going to be sure to line up like terms. And then I'm going to add them together. Now keep in mind, if you don't remember how to do column method or the checkerboard method, I do have a video on my YouTube channel. It's called Methods for Multiplying Binomials. You can check that out. So final solution for this one is y equals x cubed plus 5x squared plus 2x minus 8. Be sure, if I were you, to pause the video here, try it on your own, and then come back when you're ready. So our factors are going to be x plus 4, x plus 2. Now, typically it's x minus a number, right? It would be, you could think of it as x minus 0. Or we could rewrite that, which of course we will, to just x. Now at this point, you can multiply x plus 4 times x plus 2 and then go ahead, or you could do x plus 2 times x and then go ahead, or x plus 4 times x, whatever you want to do. I'm going to just multiply the two binomials first and then go from there. So when we FOIL x plus 4 times x plus 2, we get x squared plus 6x plus 8. We still have this x on the end. And then I have to multiply x times every term in my trinomial. And that's in standard form. All right, so we have some more vocabulary here. We have something called a multiple zero. That means we have a repeated zero. A repeated zero is called a multiple zero. So if you look at this example here, here are our factors, which means our solutions, our roots, our x-intercepts are going to be 1, 1, and -2. Well, 1 happens twice, so 1 is considered a multiple zero. Now, multiplicity is a word that really seems to confuse and concern students. So really pay attention here so that you know what to do when you see the word multiplicity. A multiple zero has multiplicity equal to the number of times the 0 occurs. So in the previous example, we said 1 is a multiple 0 and it happens 2 times. So we would say in that example that 1 has multiplicity 2. All right, so let's look at some examples. For each of the following functions, find any multiple zeros and state the multiplicity. All right, so first of all, we're going to factor number 8. It's not in factored form. We need it to be factored. We have a GCF of x squared Now, x squared could be factored more. We could write that as x times x. And then that x squared plus 6x plus 8, that could be factored more. That could be x plus 4 times x plus 2. So it says find any multiple zeros. Well, let's see here. We've got zeros at x equals 0. Right, that takes care of this. Then we have another 0 because we had 2 x's there. And then we have -4 because of this term. And then we have -2 because of this. Right, so our zeros occur here, 0, 0, -4, and -2. And we're being asked to find any multiple zeros. So we have 2 zeros, all right? So that means that we have 0 with multiplicity of 2. Because the 0 happens 2 times. 0 has multiplicity 2. Right, now with number 9, we're going to factor it. So x is the GCF. All right, our trinomial can be factored further. That's x minus 2, x minus 2. So we have zeros at 0 because we have that x there. That means we have a 0 at 0. And we have zeros at 2 and 2, right? We have this factor means we have this 0. This factor means we have this 0. So our zeros occur at 0, 2, and 2. And we're being asked to identify a 0 that is a multiple. In this case, 2 has multiplicity 2. Now, number 10 is already factored for us. I'm just going to write it out. I'm just going to expand it fully here. Because x plus 1 squared means x plus 1 times x plus 1. All right, so let's write our zeros. We've got zeros at 2, -1, -1, and -1. So in this case, -1 occurs 3 times, so -1 has multiplicity 3. And at the bottom of the page here, there's just a little recap, equivalent statements about polynomials. So if you take a look at this guy right here, and I'm going to write this off to the side, x squared plus 3x minus 4. That factors to x plus 4, x minus 1, which means we have zeros at -4 and 1. All right, so there's some, just some vocabulary here to remind you. -4 is a solution of that trinomial. -4 has an x-intercept of the graph. So if we were to sketch the graph, let's do a quick sketch of the graph. It's facing up because a is greater than 0. So we have -4 as an intercept of the graph. -4 is considered a 0, and if -4 is a 0, then x plus 4 is a factor. Okay, everyone, that's everything I have for this lesson. Thanks for watching. Have a great day.